Root 2 is an irrational number. Proof by contradiction. Proof by contradiction. Let us assume root 2 is rational. Root 2 is a rational number. Every rational number can be represented in the form of P upon Q. Therefore, root 2 is equal to P upon Q. P and Q both are integers and P and Q are co-prime to each other. Co-prime to each other. Co-prime means they have only one factor, that is 1. ये दोनों का फैक्टर क्या है? 1, right? By squaring both sides, 2 is equal to P square upon Q square. Now cross multiplying. P square is equal to twice Q square, right? P square is twice of something. Therefore, P square is divisible by 2. P square अगर 2 से divisible है तो definitely P is divisible by 2. ये equation 1. Now, let P is equal to twice M because P is divisible by 2 हमारा प्रूव हो गया तो P is equal to twice M. Now squaring both sides. P square is equal to 4M square. P square 2Q square के साथ इक्वल है. यहाँ पे P square is equal to twice of Q square. तो right, substitute P square for twice Q square is equal to 4M square, right? Now Q square is equal to twice M square. Q square is twice of something. That implies Q square is divisible by 2. अगर Q square 2 से divisible है तो Q definitely divisible होगा. Therefore, Q is also divisible by 2. ये equation 2. P is divisible by 2. Q is divisible by 2. It means P and Q have another common factor that is 2. P and Q दोनों का और एक कॉमन फैक्टर 2 हमें मिला. बट इधर क्या था? हमने क्या अज्यूम किया था? They are co-prime to each other. They have only one factor, that is 1. बट यहाँ पे हमें क्या मिल रहा है? Another factor 2 मिल रहा है. This statement contradicts this statement. This statement contradicts this statement. Therefore, it contradicts the statement. This statement contradicts this statement. Therefore, our assumption is wrong. जो हम अज्यूम किया था root 2 is a rational number, ये wrong है. Therefore, root 2 is an irrational number. Proof by contradiction. Proof that root 2 is an irrational number. पूरा डिटेल में देखो from the exam point of view. प्रूफ कैसे होगा देखो. Let us assume root 2 is an rational number. हमें ये assume करना होगा root 2 is a rational number, right? तो root 2 is equal to P upon Q because every rational number can be represented in the form of P upon Q. Where P and Q both are integers, Q is not equal to 0 and P and Q are co-prime to each other. What do you mean by co-prime? Co-prime means they have only one common factor, that is 1, right? By squaring both sides, 2 is equal to P square upon Q square. By cross multiplying, P square is equal to twice of Q square. P square is twice of something. It means that P square is divisible by 2, right? अगर P square 2 से divided है तो definitely P divided होगा. Therefore, P is divisible by 2. Equation 2. अगर P 2 से divided है मतलब P is a even number. Therefore, P is equal to twice M. 2 of something हो सकता है तो P is equal to twice M. Again, by squaring both sides, P square is equal to 4M square. P square is equal to twice of Q square. Equation 1 में है. Now substitute this. P square के जगह पर twice Q square लिखो. Twice Q square is equal to 4M square. 2 4 से cancel हो गया तो Q square is equal to twice M square. Now Q square is twice of something. It means Q square is divisible by 2. तो definitely Q is divisible by 2 होगा. Equation 2 में P is divisible by 2. Equation 3 में Q is divisible by 2. तो from equation 2 and 3, both P and Q have another common factor 2. Okay? Equation 2 and equation 3 से हमें P and Q का another common factor 2 मिला. Which contradicts the statement that P and Q have only common factor 1. हमारा जो स्टेटमेंट था पहला स्टेटमेंट P and Q are co-prime to each other, it means they have only one common factor 1. बट हमें इधर क्या मिल रहा है? Another common factor 2. दिस स्टेटमेंट कंट्राडिक्ट्स दिस स्टेटमेंट। ये जो कंट्राडिक्शन अराइज हुआ किसके वजह से अराइज हुआ? बिकॉज हमने जो अज्यूम किया है √2 इज ए रैशनल नंबर, इसके वजह से ये कंट्राडिक्शन अराइज हुआ है। सो आवर असम्पशन इज रॉन्ग। ये जो अज्यूम किया था √2 इज ए रैशनल नंबर, ये हमारा रॉन्ग था। देयरफॉर √2 इज इरेशनल। √2 इज इरेशनल, इट इज प्रूव्ड। ये हमारा √2 हो गया। अब √3, √5, √7, √11, √13, √17 सारे इरेशनल नंबर कैसे प्रूव होगा? वेरी सिंपल, सेम फॉर्मेट। देखो, प्रूव दैट √2 इज एन इरेशनल नंबर। हमें क्या प्रूव करना है? √3, राइट? तो लेट अस अज्यूम √3 इज ए रैशनल नंबर। यहां पे √2 के जगह पर √3 इज इक्वल टू P अपॉन Q। बाय स्क्वायरिंग बोथ साइड्स √3 का स्क्वायर, 3 इज इक्वल टू P स्क्वायर अपॉन Q स्क्वायर। तो P स्क्वायर इज इक्वल टू 28 Q स्क्वायर। देयरफॉर P स्क्वायर इज डिविजिबल बाय 3 because 3 times of something. Therefore P is divisible by 3. Now P is equal to thrice m. P square is equal to 9m square. So thrice Q square is equal to 9m square. Now Q square will be 3m square. Now Q square is divisible by 3. Q is divisible by 3. From equation 2 and 3, both P and Q have another common factor, that is 3, which contradicts the statement that P and Q have only one common factor 1. So our assumption is wrong. Therefore √3 is irrational, right? Same √5 कैसे होगा? Very simple. Prove that √5 is an irrational number. Let us assume √5 is a rational number. Therefore √5 is equal to P upon Q. By squaring both sides, √5 का स्क्वायर is equal to P square upon Q square. Therefore 5 is equal to P square upon Q square. P square is equal to 5Q square. P square is divisible by 5. Therefore P is divisible by 5. Since P is divisible by 5, therefore P is equal to 5m. By squaring both sides, ये हो जाएगा 25m square. Therefore 5Q square is equal to 25m square. Therefore Q square is equal to 5m square. Q square is divisible by 5. Therefore Q is divisible by 5. From equation 2 and 3, both P and Q have another common factor, that is 5, which contradicts the statement that P and Q have only one common factor 1. So our assumption is wrong. Therefore √5 is irrational, right? अब √7 देखो. Prove that √7 is an irrational number. Let us assume √7 is a rational number. Therefore √7 is equal to P upon Q. By squaring both sides, 7 is equal to P square upon Q square. Therefore P square is equal to 7Q square. Therefore P square is divisible by 7. Therefore P is divisible by 7. Since P is divisible by 7, therefore P is equal to 7m. So squaring both sides, P square is equal to 49m square. Therefore 7Q square, देखो इक्वेशन 1 में हमारा 7Q square, तो 7Q square is equal to 49m square. So therefore Q square is equal to 7m square. So Q square is divisible by 7. So Q is divisible by 7. From equation 2 and 3, both P and Q have another common factor, that is 7, which contradicts the statement that P and Q have only one common factor 1. So our assumption is wrong. Therefore √7 is irrational number, right? Now √7 के बाद √11 देखो. Prove that √11 is an irrational number. Let us assume √11 is a rational number. So √11 is equal to P upon Q. By squaring both sides, √11 का स्क्वायर is equal to P square upon Q square. So 11 is equal to P square upon Q square. Therefore P square is equal to 11q square. So p square is divisible by 11. Therefore, p is divisible by 11. Since p is divisible by 11, p is equal to 11m. By squaring both sides, p square is equal to 121m square. From equation 1, ये हो जाएगा 11q square is equal to 121m square. So q square is equal to 11m square. Now q square is divisible by 11. So definitely q is divisible by 11. From equation 2 and 3, both p and q have another common factor, that is what? 11, which contradicts the statement that p and q have only one common factor, 1. So our assumption is wrong. Therefore, root 11 is a irrational number. Root 11 is an irrational number. In the same way, by following same format, you can prove root 13, root 17, root 19, all are irrational numbers. All irrational numbers can be proved by the same process, by following same format, right?